Hello everyone. We are continuing lecture on series solution of differential equations. So in this lecture we will discuss the power series solution about regular singular point. So first of all, what is regular singular point? Suppose if we consider the standard form of a differential equation, and if x equal to x naught is any point which is not ordinary point, you can say that it is a singular point. So in case of singular, we have two types are there. So one is regular singular point, another one is irregular singular point. Now what is regular singular point? If x minus x naught into p of x and x minus x naught whole square into q of x satisfies the Taylor series, you can say that the given point is regular singular point. Otherwise, it is irregular singular point. So singular means which is not ordinary point. So regular singular point means if x minus x naught into p of x and x minus x naught whole square into q of x satisfies the Taylor series. So if it is not satisfied, we can say that it is a irregular singular point. Now, how to find the power series solution in case of a regular singular point? So that method is called Frobenius method. So in this first condition is the given point is regular point. Then there exists at least one solution of the form y equal to summation n equal to 0 to infinity Cn x minus x naught raised to n plus r. So in case of ordinary point, the solution we are assumed y equal to n equal to 0 to infinity Cn x minus x naught raised to n. But in case of regular singular point, if the given point is regular singular point, the solution we are assuming y equal to n equal to 0 to infinity Cn x minus x naught raised to n plus r, where c naught is not equal to 0 and r is the constant we have to determine. So as usual, we have to find y dash and y double dash and substitute in the given equation, that is the first step, and make all the index is n plus r and make the range is unique, that is either n equal to 0 to infinity or 1 to infinity, whatever be that, you have to make the range of each and every term is unique. So after that we are equating the least degree term to 0, so that is c naught into f of r x raised to r minus 1. Since we are equating this coefficient to 0, c naught is not equal to 0, therefore we are equating this f of r to 0. So this is called indicial equation, and whatever be the values you got from this, that r values, so that is called indicial roots. So based on that, three conditions are there when the roots are distinct and the difference is not integer. In case of positive integer, if the roots are equal, how to find the solution we will discuss in this. So finally that general solution is y equal to a y1 plus b y2. So y1 and y2 we will get depend on the nature of these roots. Now we will look at one problem. So find the power series solution about x equal to x equal to 0. The given equation 3x y double dash plus 2y dash plus y equal to 0. So first of all we have to convert the given equation in the standard form. What is the standard form? Y double dash plus p of x into y dash plus q of x into y equal to 0. For this throughout we are dividing with this 3x. Therefore we will get y double dash plus 2 by 3x into y dash plus 1 by y into y equal to 0. Now we are comparing with this. So p of x equal to 2 by 3x and q of x equal to 1 by x. So now put x equal to 0. So therefore it tends to infinity. So therefore it is not ordinary point. It is a singular point. Now you have to check whether it is a regular singular point or not. For regular singular point, what are the conditions? You have to check x minus x naught into p of x and x minus x naught whole square into q of x. Since x naught is 0, therefore x into p of x. X into p of x is 2 by 3x. So cancel this, we will get finite value. Similarly, x square into q of x. So x square into q of x is 1 by x. So therefore we will get 0. So therefore the given point is regular singular point. Now find the power series solution of this. So for this we have to consider the solution y equal to summation n equal to 0 to infinity Cn x raised to n plus r. Find y dash. So that is Cn into x raised to n plus r into x raised to n plus r minus 1. Y double dash, that is Cn into n plus r, this x raised to n plus r minus 1, that is n plus r minus 1 into x raised to n plus r minus 2. Now substitute these 3 in the given equation 3x y double dash plus 2y dash plus y equal to 0. Substitute these values. Now move this, we will simplify this. Summation n equal to 0 to infinity Cn n plus r minus 1 x raised to n plus r minus 2 plus 1, that is n plus r minus 1. So there is no change in second and third term. Now what is the first step in this? We have to make all the terms index is unique. So for this we have to make all the terms index is n plus r. So in this you have to write down this n minus 1 plus r, and you have to put one dummy variable in place of n minus 1. Put n minus 1 equal to m. Therefore n equal to m plus 1. Substitute these values in first term and second term. So if n equal to 0 to infinity, then what is the range of m? M is minus 1 to infinity. So 3 Cn, n value is m plus 1. So substitute in this n equal to m plus 1 plus r. Again in this also if you are substituting m plus 1, this plus 1 and minus 1 get cancelled, we will get m plus r x raised to. So since n minus 1 we are substituting n minus 1 equal to m, therefore m plus r. So without change this range of the summation, you can change the variable. So therefore n equal to minus 1 to infinity 3 Cn plus 1 n plus 1 r n plus r x raised to n plus r. Similarly for the second term. So in this also we are using the same method. So therefore the range is m equal to minus 1 to infinity to n value n equal to m plus 1 and n value n equal to m plus 1 plus r. Therefore m plus 1 plus r x raised to m plus r. Again we are change this m into n equal to minus 1 to infinity to Cn plus n plus r plus 1 into x raised to n plus r. Now substitute these two values in place of this and this. Now see, all the terms index is same, n plus r and n plus r. Now you have to make all the terms some range is unique. See, since it is varying from 0, 1, 2 and infinity. So this range is minus 1, so 0, 1 and so on. In this also minus 1, 0, 1 and so on. What is the common range for all the terms? That is 0 to infinity. What is the extra term in this? So that is 1, minus 1. We have to take out that minus 1 and remaining is make it as 0 to infinity. So similarly in this also. So for this in first term and second term you have to put n equal to minus 1, write down that value, and remaining is write as summation n equal to 0 to infinity. So put n equal to minus 1. If you are substituting here minus 1 plus 1 0, 3c 0. If you are putting here minus 1 plus 1 0, that is r. In this r minus 1, x raised to r minus 1, and remaining is sum is varying from 0 to infinity 3c n plus 1 n plus 1 plus r n plus r x raised to n plus r. So similarly for the second term you have to put n equal to minus 1. So if you are putting n equal to minus 1 plus 1 get cancelled, so that value is 2c 0. If you are putting here minus 1 plus 1 get cancelled, r x raised to r minus 1, and remaining is 0 to infinity. So there is no change in third term. So that is summation n equal to 0 to infinity Cn x raised to n plus r. Now simplify this. Here x raised to r minus 1 is there. Here also x raised to r minus 1. So take that common, and remaining 3c0 r minus 1 plus 2c naught r. and remaining summation is equal for this. Sum is varying from, this is 0 to infinity. So write this term plus this into x raised to n plus r. Now we are equating the least degree power this value coefficient to 0. You can't equate this. So first of all we are equating this value to 0. So 3c 0, r into r minus 1 plus 2c 0, r equal to 0. So take out this c naught common. So 3 r into r square minus 3r plus 2r. So since c naught is not equal to 0, we are equating this value to 0. So that is 3r square minus r equal to 0. So this is 3r square minus r equal to 0. So what you call this is called indicial equation. So taking this r common, so we will get r equal to 0 and 1 by 3. So these are called indicial roots, and equating this general term to 0. So therefore you have to equate and simplify this first of all. So here cn plus 1 is there, cn plus 1 take common and multiply this. So we will get cn plus 1 equal to this. Now put n equal to 0, 1, 2, 3 so on and find out the values. And once you consider r equal to 0 and r equal to 1 by 3. So put n equal to 0 and r equal to 0 in this. If you are substituting n equal to 0, this is c1. If it is putting n equal to 0 means this term is 0. So this is 0. Now we have to put r equal to 0 in this. If you are substituting r equal to 0, so this is 1 into 2. So we will get minus c0 by 2. Similarly again for the second term, put n equal to 1 and r equal to 0. If you are putting r equal to 0, this is 0 and this is 0. Whenever we are substituting n equal to 1, so 1 plus 1 2, and here also, so 3 into 2 6, 6 plus 2 8. So here if you are substituting n equal to 1, so this is 1, so 1 plus 2 5, 5 into 2, so that is 10. So that is minus c naught by 10. And whenever you are substituting n equal to 1, so this value is 1. Therefore rewrite this c naught, this c1 into this function. We will get, instead of this c1 we have to write c naught by 2. So what you will get in this c naught by 20. So similarly for this also we are substituting first r equal to 1 by 3 and n equal to 0 and r equal to 1 by 3, n equal to 1, and like that we have to find out these values. So therefore what is the final solution? So final solution is y equal to a y1 plus b y2. So how to find out this y1 and y2? If the difference between r1 and r2 is not a positive integer, the solution y1 equal to x raised to r1 into summation n equal to 0 to infinity cn x raised to n, and y2 equal to x raised to r2 n equal to 0 to infinity cn x raised to n. So this is the first condition. Whenever the difference between these two indicial roots is not a positive integer, you can write down the solution y1 equal to this and y2 equal to this. So therefore y1 equal to, so since the roots r1 equal to 0 and r2 equal to 1 by 3, so substitute in this x raised to r1 value is 0, so 0 into, so expand this c1 c0 plus c1x plus c2x square and so on. So and rewrite this c1 in terms of c0 and c2 is also in terms of c0, and take out that c0 common, x raised to 0 is 1 and we will get this. Similarly in case of y2, since second root r2 equal to 1 by 3, therefore x raised to 1 by 3 into, so expand this c1 plus c0 plus c1x plus c2x square plus so on. Again so substitute c0 c1 c2 so on in terms of c0 and take out that c0 common, we will get this and substitute these two in this equation. Like that we have to find the solution in case of the difference between these indicial roots is not positive integer. So this is the solution. So in the same way you have to find this solution. So thank you for watching. Please subscribe.